So whenever we want to add the corresponding binary numbers, add the corresponding bits from the two binary numbers starting from the rightmost bit, which is called as least significant bit. So even before we understand this rule, let us try to understand how different decimal numbers are represented in binary first, and let us try to understand what is this concept of least significant bit and most significant bit first. So if we try to understand these concepts, here are some day-to-day life numbers that we typically use, 0, 1, 2, 3, so on. These are the decimal numbers that we typically use on a day-to-day life basis. When we want to represent these decimal numbers in the form of a binary representation, so then we use the following representations. So if you want to represent 0, there are two different approaches based on the number that you want to actually represent. So if you want to only represent three numbers, which is nothing, four numbers, which is nothing but from 0, 1, 2, and 3, which is nothing but till here, you can only use 2 bits, which is nothing but one place, and this is the second place. You can fundamentally use only 2 bit values in order to represent any number between 0 to 3. But if your numbers are increasing, that is, if you want to represent any number greater than 3, so if you want to represent 4, 5, 6, so on and so forth, we might require something called as a 3-bit representation. So if you look at the number 0, it can be represented as 0, 0, 0 in a 3-bit representation. It can be represented as only 0, 0 in a 2-bit representation. If you want to represent the number 1, then you can write it as 0, 1. Why are we writing this as 0, 1? Look at this very closely. What do we mean by 0? That is what we said. Whenever we have a base 2 representation, we need to multiply to the powers of 2, which is nothing but you are multiplying with 2 power 0, 2 power 1, 2 power 2, so on and so forth. Plus, now you have the value 0 here, and this should be multiplied to 2 power 1. So this is going to be 0 plus 1 into 2 power 0 is 1 itself. So therefore we are writing 1 here. What is 0 plus 1? It is 1, right? That is how we have obtained this value 1 in the representation 0, 1 in a 2-bit binary representation. And look at this very closely. Whenever you want to represent the number 2 in decimal in the form of a binary representation, you are using the notation 1, 0. Why are we using this notation of 1, 0? Let us try to similarly break down the idea. So here you have 1, 0. What does this representation mean? This means take this value 0, multiply it to 2 power 0, plus take this value 1, multiply it to 2 power 1. And what is the resulting value? 1 into 2 power 1 is 2, plus you have 0 into something, so this is definitely 0.